couple of examples of some nets that I've already cut out, okay? So again, I'll look at my first example. Let me just put a blank sheet behind us though, so we can see it a little better. So as you can see, it's got 2 hexagons. The fact that there are 2 hexagons, and those really are unique shapes, that is my first indication that this might actually be a prism of some sort. So I'm going to go ahead and fold my shape along the edges, and let's see what kind of shape we do end up creating. And again, notice all of these sides are rectangles. So I've got 2 prisms, I've got 2 pentagons that seem to be acting like bases. And then I've got rectangles for the sides. Now, I don't happen to have tape, but as you can see, we do end up with a prism. So a hexagonal prism. So that would be an example of our hexagonal prism. Here's another example. Again, I notice we've got triangles for sides. Triangles for sides. Looks like we have a square for a base. So again, if I fold along my edges and I look at what my 3-dimensional shape ends up equaling, now the fact that there's one base that's unique and the sides are triangles, that's going to be indicative and indicate to me that this is probably going to be a pyramid. And lo and behold, look at what we get. We do get a pyramid shape. Okay. So using this information, let's go back to our example. So again, this is a different way the net might be cut, but notice we've got 2 hexagons and we've got other sides that are rectangles. This tells me that it would be a hexagonal prism. Now our next one's very interesting. Now look at the shape of the base. There's one base that's a circle, and then we have this curved bottom, and it comes to a point. Well, the only shape I can think of that's a solid that has one circle for a base would be a cone. Let's look at our next example. Here you can see we have a pentagon in the middle, and we have some triangles. So there's only one pentagon. The other sides are triangles. That tells me they're going to come to a point. This would be a pentagonal pyramid. Let's look at our next example. Now this one's interesting. Now look, we've got 2 sides that are big rectangles. Then we have another set of sides that are little rectangles, and another set of sides that are rectangles. This would be a rectangular prism. And last but not least, here we can see we have a triangle and then sides that are triangles. So this would be a triangular pyramid. Okay. Now sometimes we're going to be asked to take a cross section of a solid figure. Okay. So a cross section is an intersection of a 3-dimensional figure and a plane. I almost think of it as slicing the shape. And it's going to be sliced with a nice flat surface. I almost think of it as if I slice the surface and I pick up the piece and I look at what I have left, what shape would I have? Now, there is a maximum number of sides a cross-section can have, and that's equal to the number of the faces of the solid being cut. So if there's 7 faces, then the maximum number of sides could be 7. Now let's look at some examples. Now this one comes from your textbook. So again, it's in section 4. So how would you describe the cross-section? Well, here's the important piece. Depending on how you slice, quote unquote, slice the figure, can impact the shape of your intersection. So here's a couple of examples, and we'll talk a little bit more in depth. So in our first one, you can see here we have, it's literally slicing down my hexagonal prism. And the direction that it's slicing it, you can see that we end up getting a shape of a hexagon. Now if I look at my next example, slicing it across, parallel to the base, since its base is a triangle, the shape of my intersection is going to be a triangle. Now here's where it gets interesting. Example C. Now they are slicing it perpendicular to the base, straight up and down. If I were to take this little bit off and I look at the side, the shape of what's left would be a rectangle. But if instead of taking my slice this way, instead if I took it this way, if I did this direction, it would be a circle. So depending on how you quote unquote slice or cross section the solid is going to impact the shape that you get. Here's letter D. Now in letter D, you can see we're parallel to the base. The base is a circle. And so therefore, if it's parallel to the base, it's going to be a circle. Again, if I cut it up and down perpendicular to the base, now my shape would be a triangle. Letter E, we have a sphere. Our circle would be the cross section. Now on letter F, this is interesting. We have some sort of a rectangular prism. Notice we're doing it on an angle. This time we're getting a slightly different shape. We are going to be getting some sort of a trapezoid. Okay. So how you cross-section the solid will impact the shape you're going to get. And again, I always say, think of it as if you take and you were to cut and you were to pick up the piece you cut off and you look at the shape of what is left, what is that shape? And this one was a trapezoid. Now, sketching and describing solids of revolution. This one can be kind of hard to think about, and I'm going to attempt to find a video that you can watch that will maybe show you an example of this. But there's always going to be a shape. Now this one happens to be a rectangle, and there's going to be an axis that you're going to rotate that rectangle around. And I always think of it as, if I were to move this super fast, really, really fast, and spin it very fast, what shape would it look like I'm making? That's really the question we're asking. So if I were to take a rectangle and spin very fast, and it doesn't matter which direction, if I'm going clockwise, counterclockwise, it doesn't make a difference. If I rotate really fast, I'm going to end up creating a cylinder. So let's think about this. All right. If I were to, now I have terrible artistic skills, as we all know, but if I were to rotate this rectangle along this axis of revolution, I'm going to end up creating some sort of cylinder. Now we have a better looking picture of it down here, but you can kind of get the idea. The same thing here. If I have a triangle and I'm rotating around this axis of rotation, well, I know it's going to come over here. It's going to kind of be like this, make it rounded. I'm going to end up getting a cone. The most common rotations that we're going to see involve triangles, rectangles or squares, and semicircles or half circles. If I have a rectangle or a square and I rotate, I will create a cylinder. If I have a triangle, either a small one or a bigger one, and I rotate, I will create a cone. And if I have a half circle or a circle and I rotate, I will create a sphere. I hope everyone is doing well, and I look forward to speaking with you again next week. If there are any questions, please feel free to email me. Thank you. Have a good day.